Thank you all for coming tonight. Our speaker tonight is from PJM Interconnection. They are our local independent systems operator for electrical power. They basically manage the high voltage transmission in the whole area, and they also establish a wholesale markets for electricity. And Steve is going to be talking about cybersecurity on electric power systems. I guess I'd like to introduce Steve McElwee, and Steve is the head of cybersecurity at PJM, and I'll let you explain in more detail where you're coming from.
Okay. Thank you, Alex.
You have your own mic.
I have my own. Members and guests of Incose, it's a pleasure to be here with you tonight and talk to you about cyber threats on the power grid. The power grid is a fascinatingly complex system. There are a number of things that make it such, and I've tried to portray it as a system with inputs and outputs. I'm not a systems engineer, so I may get some of the approach wrong, but in general, if you look at the power grid and you see at the inputs, we have your typical fuel mixes. You have natural gas, you have coal, uranium, different things that fuel generation. Generation it takes a number of forms, and newer forms are things like wind and solar, which have totally different characteristics. But one of the interesting characteristics, and I think the things that makes the power grid fascinating, is that there's diverse ownership. There are a wide variety of owners of generating units, and as we move further and try to move that power from the generating units to the load, the people that use that power, we need transmission. And the transmission itself is also owned by multiple companies, and they work together. Just below that, you see there is the concept of an ISO and RTO, and that's where PJM fits in. We are an RTO, Regional Transmission Organization. We're responsible for operating much of the generation and the transmission that's owned by these different companies. I call that the power grid. There may be different definitions of power grid, but I thought for the purpose of tonight, we'll frame it that the generation and the transmission and the role of the ISO and RTO is the power grid. But it goes further than that, because there's also diverse ownership of distribution. The distribution is what takes the high voltage that comes through the transmission towers and converts it to a lower voltage that can be distributed out to the different together with inputs and outputs. The output is intended to be a reliable 60 hertz level of power. And there are a lot of supporting communication and supporting processes that make that system work. And it really takes many different forms. It goes well beyond technology. It looks at people, it looks at technology, it looks at process, and ensures that we have reliability. And when I first got into the electricity sector, it was just 6 years ago, I really thought of electronics as the way to describe power. I have a little bit of a background in electronics, and I thought, well, you have consistent, reliable power sources, and the rest of it is all Ohm's law and Kirchhoff's law. And I was wrong. I think the power grid is very fascinating because of the number of components, the different aspects that I'll be talking to you about. The power grid is also not one single grid. I think it's important to note that the power grid is a series of interconnections. And this slide, I say one power grid or four. There are four listed on this diagram, but technically you could say there are five. There are two major pieces of the power grid, which are the eastern and the western interconnection. And the eastern interconnection is where PJM sits, and the western interconnection has pretty much from the Rockies west would be the western interconnection. But then Texas, most of Texas has its own interconnection, Quebec has its own, and what's not shown here is Alaska has its own interconnection. And what it means to be in an interconnection is that power is synchronized. The 60 hertz that we receive in our homes and businesses is all synchronized, and there are a lot of electromechanical machines that are spinning in a synchronized way. If that power grid were extending over the whole area, every single one of those generating units would have to be synchronized. So there's some advantage in having separate interconnections that allow that synchronization in a smaller area. There is some sharing of power between those interconnections, generally by DC ties. Since DC doesn't require any synchronization, it allows power to flow as needed between the interconnections. And there's also some variable frequency transformers that are used in Quebec. So one of the important things to keep in mind when it comes to securing the power grid is that synchronization is key. If things become unsynchronized, then we start to have differences in power distribution. We start to have stress on the system and stress on the transmission lines. And so a key component of securing the power grid is understanding what is the negative consequence that we're trying to secure. In terms of where PJM fits in, we have a piece of the Eastern interconnection. We don't operate the entire Eastern interconnection, but you can see that we have a large portion of the Eastern interconnection in terms of megawatts that we provide, as well as representing 21% of the U.S. gross domestic product. So you can see that we have a very large span of control. We cover 13 states plus DC, and our maximum generating capacity is 183,000 megawatts. So that's a lot of power. That makes us the largest RTO by definition of megawatts in North America. At PJM, we focus on three main things, and really only those three things. And the first is reliability. As I talked about synchronizing the generation to make sure it's all operating at 60 hertz, we do that by matching the generation to the load and making sure that within that short time frame that electricity can actually be on the wire, sub-second time frame, that we have adequate generation to match the load, the consumers that are using that electricity. And that's our primary focus. Everything else that we do is secondary compared to that. We also operate a real-time energy market and a day-ahead energy market where we are trying to balance the economics with reliability. And we're using economics as a driver to build capacity into the grid and make sure that when we're in need of calling up generation, that it's there under different normal conditions, as well as ancillary services that we require, like black start services and things like that, that are essential to operation and managing risk on the grid. But we also have a third function, which is equally important, which is long-term planning. We take a 15-year view of where do we need new generation, where do we need new transmission, how do we make sure that we are able to serve the load across the transmission lines when generation is not always where the load is. So we have to transport that over long distances. And that's a key function of PJM. And as I'll talk about, that's also a very key role when it comes to cybersecurity. At PJM, we're kind of like air traffic control. We don't own the planes. In our case, we don't own any generation. We don't own any transmission, but we operate it. We make decisions about what needs to happen in terms of raising generation or lowering generation, how power needs to be rerouted, and it's based on a wide situational awareness, a wide-angle view of our area, where one transmission owner would not be able to see their role in the big picture. We're able to see a much broader view and able to make sure that generation serves a much wider area. So I mentioned that the power grid is a fascinatingly complex system. It's also a system that our lives depend upon. And I use this as an example. It's the 1977 New York City blackout. This goes back a number of years, but lightning struck in the Con Ed area, and it tripped 2 circuit breakers. And those breakers resulted in the main generating unit for the New York City area to go out of service. And as a result, New York City had a blackout that lasted about 24 hours. What ensued was a lot of rioting and looting. The city, in many ways, fell into chaos. During those 24 hours, over 1,600 stores were looted. There were over 1,000 fires that were set. It's estimated that there were over 3,700 people who were arrested just in those 24 hours because of all the crime that ensued. There were about $300 million in damages caused just by the looting and the vandalism, not to mention any economic consequences that may have resulted from that. I bring this up to mention that the electricity that we rely on is vital to our society, to our economics. It's something that when it goes out, there's a level of stability that's lost. And in some ways, you could say it's the mood-stabilizing drug of America. If you don't have it, things do break down quickly. And so, how long can we live without electricity? It's vital for just about everything that we do. So the power grid is fascinatingly complex, and our lives depend upon it, and it's constantly under threat. As I mentioned, the power grid can be looked at as a system. And if you look at it as a system, what are the threats at different points in that system? I mentioned one threat at the input, which is natural gas. One of the most turbulent things going on right now in the power grid is the generation mix. We've relied primarily on nuclear and coal, and for many reasons, things are shifting. In some cases because of coal retirement, coal units that are being taken out of service, but also because of the cheapness of natural gas. PJM sits on top of Marcellus Shale, which really is changing the dynamics of fuel for generation. And so natural gas is becoming a primary driver for generation. It's in our 2015 and 16 auctions, we noticed that about 95% of new generation was natural gas. So what we're seeing is a major shift in the economics of the grid, the fuel sources of the grid, and I think as a result also the risks associated with the grid. This is a natural gas plant in the Duke area, and these are fed by natural gas pipeline, and one of the risks that we've encountered in the last year is cyber attacks on the natural gas pipeline. They started as a campaign, and they started in 2012 and continued into 2013. And that campaign resulted in breaching many natural gas companies, stealing plans, and gaining possible footholds in those companies. The compressors that help push the gas through the pipes, plans for those have been revealed, and so there's considered to be many vulnerabilities associated with that could be exploited. So if you're able to somehow cut off the flow of natural gas and our generation mix is changing so that we're relying on natural gas, that would be one way to have a significant negative effect on the power grid. And it could be accomplished through cyber means. So it's an area that we need to look at carefully. So this is one threat, but if we also look at threat at the output, one of the ways that we see the grid changing is the smart grid. And the smart grid promises a lot of different things. There's a lot of potential for the smart grid. One of them is transparency. And we see transparency by sending price signals all the way down to the consumer. And one of the ways that this is manifest is with smart meters. And smart meters have gotten a lot of press as to, are they secure? Do I want that in my house? And there are a lot of mixed views. Some people are very positive on them, and some people are very negative on them. Smart meters can be a big benefit for us, but at the same time, if they're compromised, they can be a great risk. Because if you have one smart meter it could introduce a door into the power grid. But by isolating it through different protocols, you can really minimize that risk. But what happens when you have two smart meters, or 3 or 4? And what happens when you have thousands of smart meters? Suddenly, you have the ability to control more of the load. And by controlling the load, that's one piece of our equation, balancing the generation and the load. When you're able to throw that off, it can have very negative consequences. And one of the cybersecurity things that's been going on for a very long time is what's called a botnet. And if you're not familiar with the botnet, it's when you compromise one computer and make that spread to multiple computers. And suddenly you have thousands of computers. And when you have a botnet with thousands of computers that have become bots, they're under the control of what's called the bot master. And as a result, we've seen these botnets being used for denial of service attacks. Your home computer could be part of a botnet, and you wouldn't even know it unless you take certain precautions to secure it and regularly check on it. Well, what happens if we take that model of a botnet and we apply it to smart meters? If you're able to compromise a smart meter and gain control of it with a single bot master, suddenly you can simulate changes in load on the grid. Without that change actually being there, you could fabricate sudden load on the grid. Or even worse, you could, through changing what the smart meters are doing, discontinuing service or disrupting service, you could suddenly switch on and off that load, making it nearly impossible to control changes in the load. At PJM, we forecast load on an hourly basis. We have curves that show where we expect load to be over the next 24 hours. And it generally follows pretty close to our forecast. But if someone's controlling all of the load out of our control, we would have no ability to forecast that. And that could cause a significant challenge for us. So this is one of the threats at the output. We also have threats to the whole process itself. The blackout of 2003, the Northeast blackout, was a pivotal event for the electricity sector. What had happened was it was an 88-degree day, which was a little bit warm. When the temperature is warmer, there's more demand for electricity, for fans, for air conditioners. And when there's extra load, it causes the transmission lines that we operate to heat up. And when they heat, they begin to sag. So on this 88-degree day, on August 14th of 2003, the lines were beginning to sag, but it was more than that. Systems are more than just the technology. They go into many areas, and the blackout of 2003 touched many areas. So it was the sagging lines, but there was also a software bug in an alarm system at First Energy. And that software bug would play an important role. At Midwest ISO, which is a similar company to PJM, but west of us, there was a problem with their state estimator. The state estimator is what helps us to understand the security of the grid in terms of how stable is it, how are we maintaining the power within voltage and thermal limits to operate safely. And Midwest ISO's state estimator had incorrect data, and it was shut down, so they were unable to receive important information that would be needed. There was one generator in Ohio that ended up shutting down because of problems. They were having recurring problems, and when it did shut down, it caused a shift in power through the grid. And as it shifted, it caused one of those sagging lines to sag even lower, and it made contact with a tree. So now we have the line intersecting with a tree, meaning it would short to ground, and as a result, it was a 345 kV line that sagged. When it tripped the line, it caused additional lines to trip. And when those lines tripped, it caused more tripping of lines because it was rerouting power, and the system wasn't able to handle that. Now, in most cases, the assets that were out in the field were not damaged beyond repair, but when you have a large system, that shuts down over multiple states, it can be very challenging to bring that system back up. It has to be done in a certain order and be done with care. In addition, there was, at First Energy, there was an alarming system that failed, so people weren't able to see some of the alerts that they could have seen that could have stopped it. The net effect of that was a cascading outage that covered many, many states, caused a lot of economic loss. It shut down 508 generating units. That's a lot of power to go out of service, and affected 55 million people. It lasted about 2 days. It's hard to say how long it lasted, because for some the power came back more quickly, but for some it lasted as long as 2 days. Rail services were shut down in many cases. Flights were canceled. There was even some loss of life that was attributed to the power failure. So you can see in this case, and I bring up the blackout because when it comes to a threat against the power grid, a threat of that magnitude requires a threat against multiple components of the system. One thing by itself might not have caused a cascading outage. If there wasn't a software bug, if the state estimator was working correctly, there's a good chance that this would have been identified more quickly. There might have been some smaller geographic range that would have been affected, but because of multiple issues, threats at different points in the system, it caused a large-scale cascading effect. But there's more than just threats to the system. There's another type of threat which is even bigger than that, which I'm calling BHATs. If you've ever read Good to Great by Jim Collins, he refers to something called BHAGs, Big, Hairy, Audacious Goals. And I would say that there are some threats that we would characterize as big, hairy, audacious threats. And the reason for that is they're too big for us to even figure out, how will we defend against some of these. There's measures that we can take. There's a level of resilience that we need to maintain. But there's some things that we may have little control over. When it comes to solar flares, as solar flares are approaching us, they can cause an induced current in the ground that can damage electrical equipment. And we know that we're at the peak of the cycle of the sun where we'll get the most intense solar flares, coronal mass ejections that hurl these solar flares towards Earth, and if they hit at just the right angle, at just the right spot, they can cause damage. So far we haven't seen significant damage, but there's a lot that could be done with them. In addition to that, we have the threat of EMP, electromagnetic pulse, and that's a looming threat that if someone were able to detonate nuclear weapons above the Earth's atmosphere, the resulting electromagnetic pulse could wipe out much of our electronics and our electricity infrastructure. So we have these threats, and we would also call these the high-impact, low-frequency threats. They're things that are events that could happen. If they do happen, they're huge, but you can't always predict what will happen and when they'll happen, also called black swan events. So we know that the power grid is a very complex system. Our lives depend on it, and it's under constant threat. But I think it's important to note that industry and government are taking great measures to protect it. One of the areas that we're working on to protect the grid is at the physical level. It's funny to say this as a cybersecurity guy, but I think some of the best protections for the grid are at the physical level. The picture here is of a switch yard, and there are many switch yards and breakers and things that are responsible for helping us to control the flow of power, and in some cases reroute power when needed, stop it from certain points. As I mentioned in the slide with 3 gears, planning is an important component of what PJM does. And I bring that up because it's a result of this long-term planning and understanding where do we need to physically protect the grid, that we can isolate any impact that's caused by any type of threat, whether it's a cyber attack or an overgrown tree. These are all things that can have a negative effect, but how do we keep the physical consequences to a minimum in a way that will be manageable? In the 2003 blackout, the blackout only touch the edges of the PJM boundary, the area where we're controlling. And I say that not to brag on our efficient operation and our quick response to the emergency. This was something that happened in a matter of seconds. It's not something that a human could have intercepted and made changes. But really what impacted the blackout and minimized the impact for PJM was the system protection mechanisms that we had, the breakers at the right location, the right technologies at the right spot. And that's where the role of planning comes in to help ensure that we're able to maintain and sustain the grid. Whether it's a physical high-impact, low-frequency event that could touch the grid or a cyber attack, any of those could be significantly mitigated through planning. One of the areas that we're working on in terms of planning for some of the bigger types of events, in terms of solar flares and ground-induced currents, PJM has been studying where are the areas on the grid that we're most at risk. Where are we most prone to ground-induced currents? And how can we modify our operating procedures so that we operate more conservatively? If we know that there's a solar flare on its way, how do we operate conservatively in our transfer limits to make sure that it'll minimize the impact? We're also looking at equipment, in some cases replacing equipment to minimize the impact that could exist on that equipment, looking at grounding as well as additional GIC monitoring to make sure that we understand the characteristics that could cause that threat. Electromagnetic pulse is a little bit more challenging. There's not as much that we can do about it, but there are studies that are going on regarding hardening, making sure that we have adequate communication to work through an EMP incident, making sure that we have emergency supplies on hand, fuel and backup power. So you can see there's a lot going on, and the physical layer really is one of the main keys to making sure that we secure the grid. But there is the cyber layer, and that's the area that I work in, and there's a lot that we need to do there as well. And I've portrayed this also similar to a system in that the main thing that we're dealing with when it comes to the cyber threat is the cyber attack. There's a lot that we do that we call security, but we don't always tie it back to that main input that we're trying to address, which is the cyber attack. And I've represented some of the things that we're working on to mitigate the risk of that cyber attack. And the first is defense. The ability to slow down the attack, hopefully stop it, but we recognize that a persistent and well-funded adversary is going to make their way into our networks, into our systems. But how do we slow that down? How do we make it harder for them? We're also looking at response, making sure that if anything does make it onto our networks, that we're able to quickly identify it and respond as quickly as possible in a consistent way and recover from any side effects of that attack. But we go further than that and recognize that a lot of what we need to do is education. Education of our end users, the people that are using our systems. As we secure our systems, there's still the human element where we can't always control what the users will do. And I'll talk a little bit more about some of the threats that we're facing there. But we go further than that, and this is where we go beyond the traditional IT security, and we look at partnership. As part of critical infrastructure, we've recognized that we can't do this on our own. And so we work on partnerships that allow us to leverage government resources as well as the expertise of other individuals and organizations within the industry to collectively pool our resources together and make sure that we have adequate response plans, make sure that we're using the best of technology, and doing everything that we can. Now we're doing this in the context of risk. One of the things that we need to do is recognize that in private industry we don't have unlimited resources to throw at the cyber challenge. That's an important area for partnership where we can work with the government when it comes to defending critical infrastructure. They play a key role in that. But as far as our investment in it, we need to manage that through risk, identifying what are the top threats that we need to address and what are the measures that can help us to improve our defense, our response, our education, as well as our partnerships. Another area that we're working on is developing metrics around cybersecurity. How do we measure the effectiveness of our defensive measures? How do we measure our ability to respond quickly? And we're looking at things like kill chain analysis to allow us to better describe and articulate what is the threat, how far did it make it, where did we stop it, where did we detect it, and use those metrics as an input back into the risk assessment. So we have a feedback loop that allows us to continuously improve our security posture in all of these areas. One of the areas that we're looking at in terms of defense, how do we defend against the attack or at least slow it down, is vulnerability management. And I call vulnerability management an umbrella over many things that we're doing. If you're in security, sometimes vulnerability management means you run a scanner and you follow up on results. But we see it as much more comprehensive than that. It begins with patch management, really. One of the things that we really strive to do is to keep our systems patched. One of the easiest ways to break into systems is to find software vulnerabilities that companies haven't patched. And so we're spending a lot of time and effort to improve our patch management process. We're also looking at vulnerability assessment, running those scanning tools and following up on results with committed teams dedicated to doing that work. We're also doing penetration testing against ourselves, using third parties as well as doing some of our own work. And we've established a security assessment committee that provides security expertise from different areas within the organization to review any new software, any new projects, and ensure that we've identified all of the cybersecurity risks and that we've put in place measures to correct those. And together that provides a nice defensive tool for us. It's one of many things that we're doing, but it's one area that's very important to us right now. Another area that we're working on in terms of response is round-the-clock monitoring. In the past, we've relied on our security incident and event management tools to alert us when things were wrong, and after hours we would hope that we were receiving the right alerts and following up. Over the past couple of years we've changed that model. We recognize that some of our nation-state adversaries don't work our business hours, and so we need to shift our business hours to accommodate when they're attacking. And so we now have a round-the-clock monitoring that we provide using an outside managed service to help, first of all, keep eyes on the glass around the clock to make sure that we understand what incidents are coming in, that we can collectively look at incidents and see bigger trends, things that we couldn't do if people were just being emailed alerts here and there. We have a level 1 team that does that round-the-clock monitoring, and then a level 2 team that follows up and whenever something is escalated, when it's beyond the control of our level 1 team to perform. This has been a tremendous success for us. We've certainly found a lot more since we've started going to this level, and we continue to work to improve our process and better understand how can we keep any attacks that we are seeing off of our systems. Another area that we're working on, which is essential to that system of defense and response, education, and partnership, is really focusing on how do we educate end users. One of the biggest threats that we face today is spearfishing. Spearfishing is a key vulnerability because it doesn't matter what security defenses we put in place. If someone clicks on an email that has some type of threat or some type of malware in it or a malicious link, suddenly their computer can be compromised. And that one point of entry, that one person who didn't discern the threat that was in that email, suddenly can result in an entire network being owned. So at PJM we've been taking it very seriously. Over the past 2 years we've been running simulated spearfishing campaigns against ourselves. And in that we're able to use an outside service that we craft spearfishing emails, send it to our entire user population, and when someone does click on a link that they shouldn't have clicked on, they get real-time, immediate response, a message that says, "You've been phished, and here's what you should have seen in this email that could have helped you to understand that this was not something you should click on." We found a tremendous amount of success in that, and we've seen that When we started out our phishing campaigns, we were at a 20% click-through rate, the number of users that clicked on links that they shouldn't have. And through month after month campaigns against our own users, and through this real-time situational training, we were able to bring that number down to 4%. So we feel really good about that, and that puts us ahead in many cases where a lot of folks in our industry are, and folks in different industries. But 4% is still significant because it only takes one. And so we continue to drive home the importance of human behavior and helping to understand the security threats that are out there to make people more wise about their choices in opening email. The other area that we're working on is in partnership. So we have many partnerships that we work on with different government and industry organizations, and I bring out one that I think is probably the most promising of what we're working on, and it's called the Cyber Risk Information Sharing Program. This program was originally started by the Department of Energy, and it was a way to better understand the threats on the networks of industry. It came from a program in the Department of Energy which was called CPP, and it was used to monitor Department of Energy organizations' networks. We deploy an information sharing device on our network, and it sends the data, kind of the characteristics of the network traffic, to Pacific Northwest National Laboratory, where they do analysis on it. This is the same model that they used in the Department of Energy. They've rolled it out for 4 pilot participants. PJM is one of those. So we have data going out to PNNL. It's kind of like the information about your phone calls. It's not the content of your call, but who did you call, how long did you talk, those types of aspects. There's certainly a big brother connotation when you start sending data off to a government agent or an agent of the government. But we've managed that carefully, and we think that it has a lot of promise for us. We're sending flow data, which is the information, like I said, who's talking to who, how much data is being sent. We're also using snort signatures. So PNNL has developed custom snort signatures based on intel that we don't have, and we don't always need to know why or the attribution behind those signatures, but they push the signatures out to our information sharing device, and they're alerted when they see something that matches the characteristics of that threat. And they also use a program called AMP, which looks at some of the header data on DNS requests as well as HTTP traffic. And by doing this, they're able to see what's going on, and they're able to tie that back, in many cases, to classified information. We do have a number of people at PJM that have clearances, but all of them are at the management level. And when it comes down to it, if I run off to a security briefing, I learn a lot of things, and I go home scared, but I can't tell my analysts who are actually doing the real-time monitoring anything about it. And so CRISP is an excellent way to establish a better public-private partnership, because when there's something suspicious that they see on our network, they give us a call and they say, hey, here's an IP address that you need to block. And we can proceed and we can block that IP address and never know that it was, the nation state of the day that was attacking us. All we know is that someone's watching out for us, and it helps a lot. The partnership has expanded. Moving forward, there will be additional participants. We're looking at 20 new participants in the program with a goal of expanding the program to get broader industry value, because the power grid isn't just about PJM. It's about all the transmission owners, all the generation owners that make up the entire system. So the broader reach that we have with CRISP, the better we'll be able to quickly identify and respond to threats, and the better partnership we'll have between government and industry. We're also working in this with Argonne National Laboratory. They have what's called the CyberFed model, which is an information sharing mechanism that will allow us to securely receive characteristics, analytical information about the data that we're sending. And more recently, the ESISAC, which is North American Electric Reliability Corporation, NERC, they are getting into CRISP, and they'll be working as the program manager for that moving forward. And as the ESISAC, they are an information sharing portal themselves. So it's really putting industry at a good place in terms of partnership, but also in terms of understanding and identifying the threats that we face. So as I mentioned in summary, the power grid is a fascinating system. Our lives do depend on it, but it's under constant threat. And I hope that through these examples, you're able to see that industry and government are working closely together to protect it. Thank you very much. I'll take any questions that you have.
Any questions in the crowd?
I'd like to lead off with a question, if I may. Has CRISP involved the Defense Department or the National Security Agency side of the world? They seem to be missing from this community, and I was wondering if you've had any interaction with them.
We have not had interaction with them at this point. The information is largely tied to the Department of Energy and different analytical centers that they have. We haven't talked about that. One of the things about CRISP is that we have, we as industry, we always have to balance information sharing with the government and cooperation with the government with also making sure that we establish clear boundaries. And we have information sharing agreements that allow us to determine who will we share our data with. So we're able to understand, at a very detailed level, which data will we share and with whom among the partners in the program, the participants, as well as with the government agencies that have access to the data. And right now, the NSA and the Department of Defense are not groups that we've even talked about.
For our next question, if you haven't yet gotten a green ticket, please raise your hand. Our secretary will come around and get you one. Thank you.
Steve, thank you for your presentation. I have a question about, if I understood correctly, PJM is the RTO. I mean, they are the operator of transmission. So how you communicate or how you identify the assets owned by transmission owner or generator owner, and you order them to protect their assets?
Well, PJM isn't required to order them to protect their assets. There are, one of the things about the process that's important is with independent ownership, how do you coordinate all of that? And one of the things that we rely on, especially as a result of the 2003 blackout, is there are mandatory standards. And so each of us must comply with those mandatory standards. And that requires consistency in how do we protect the system with relays, how do we operate at 60 hertz, how do we even communicate what needs to be done with three-part communication. So there's a lot that's driven through common standards that we rely on. But in addition to that, we have a lot of cooperation with our transmission owners and generation owners at multiple levels. One in the planning process, but also in the operation of our markets to make sure that as they participate in our markets and they want to sell that capacity, that generating capacity, we're able to coordinate with them there and balance economics and reliability.
Question here. I hear about Internet Protocol version 6, and it's supposed to be more secure. So will IP version 6 make all your problems go away?
It depends. If you don't roll it out properly, it could add problems. That's one of the challenges. I think there are additional security features in IPv6 that can help us. The bigger problem is adoption. It requires system changes, a lot of process changes. Some companies are making that shift, especially companies that have a wide IP address range that's exposed on the internet. At PJM, we haven't made that transition yet. We don't see that the security benefit is that significant right now to warrant that investment, but it's something we are looking at and monitoring closely.
Hi, I've got two questions for you, sort of related. The first one, you characterized real well this notion of, I'll say, threats at the edge, both on that input and the output examples. I'm wondering if there's any way that you're able to look for or monitor through any of those means of security what I like to call the outsider-insider threat. So these would be things inside your system, inside a firewall, so to speak, that are not critical, and therefore not necessarily at the same level of monitoring. A lot of those other components and things like that out at substations and such. And then related to that, there's a lot of buzz right now about counterfeiting and supply chain threats in the computer world. I'm wondering if supply chain and counterfeiting has become an issue yet in the energy control sector.
Okay, great. Good questions. I think, first of all, in terms of insiders in the process and the threats that they pose, that's a very real threat. That's something that we can see today with Edward Snowden, someone who's inside and has privileged access to things and suddenly causing ripples throughout the system. We are continuously monitoring. One of the areas that we really focus on for insider threat is our monitoring, making sure that we're able to detect incidents that could point to inappropriate access, excessive privileges, or escalation of privileges. We're also working on developing an insider threat program that is based in some parts off of work done by Carnegie Mellon, they've done outstanding work in that area. So we're continuing to work on maturing it. It's a very tough area for anyone to crack. When you have a trusted individual, especially with privileged access, at one level you have to trust them, but at some level you must somehow monitor to mitigate that threat. Regarding supply chain threats, that's an area that we in industry find very challenging. The reason is because any information about supply chain threats is generally reserved to cleared meetings and information that's classified at a level that we don't have access to. So as we hear about threats for backdoors in systems or at the hardware level, we don't have right now the tools and capability to verify that or to test that equipment to verify that. It is an area that we're exploring, but we're continuing to look at that as an outstanding threat that, again, we rely as a mitigating control on monitoring. If there is something even that has a backdoor in our system, we do have significant monitoring at multiple levels that we would hopefully detect that quickly and be able to respond. But it is an area of lower maturity.
Relative to threats getting in on the power system affecting cybersecurity, if you have a transient disturbance, lightning, or well, EMP is the worst case. There are possibilities, and they can, in those small time increments, inject something through the power system into your computers. There are people working on that in cybersecurity in some companies, just like Stuxnet was many years ago, but that's morphed into a number of different types of threats. And I was, there's an outfit group, Stop EMP and so on, trying to lobby. And also, the other question is, does the power system monitor anything to like solar mass ejections and correlate those with the storms that affect the power grid? I know the Japanese may be interested in, back 40 years ago, DNA was doing studies on the lines, undersea lines for EMP and problems in the ionosphere, where you do get an induction into the power system or the communications lines. So I was wondering if you're looking at those threats.
Yes, we are continuing to look at things like ground-induced current, solar flares, looking at how do we get advanced warning of those and be able to change our operating modes so that we can better address that. Again, we can't stop it, but it's something that through better understanding of the threat, monitoring it, and taking precautions in advance, we're able to help to mitigate that threat. I can't address all of the areas that you talked about, but I think that tends to be our approach, is to better understand the issues and adjust how we operate to affect them.
I heard you mention standards several times. From a cybersecurity perspective, do you participate in at either regional, national, international level? Do you participate in standards development activities, and if so, what's your focal point?
Our primary focus with standards is the NERC CIP or NERC CIP standards. We've participated in standards drafting teams to help shape the new version that's out there. The version that we have in place right now is a little bit dated. It's been in place for a number of years, and the cyber threat landscape changes very quickly. The new version that's subject to FERC review right now promises a lot more protective mechanisms, a lot more robust security than what the original standards offer. But that tends to be our focus in terms of cybersecurity. There aren't a lot of mandatory requirements for us at the cybersecurity level, nothing regional or at a local level that we are required to comply with. We do look at other standards that aren't mandatory, though. We look at things like ISO 27001, especially as we look at risk management, using that as a standard practice for identifying risks and applying risk treatment plans. We also do leverage, in some cases, the NIST standards, 800-63, I believe it is, for cybersecurity controls. But the ones we really focus on are the NERC CIP standards.
Thank you for your presentation. You described these high impact, low frequency. The high impact, if we had a long-term electrical outage, it would cost trillions of dollars. The consequences, even if it's a 1 in a 100-year event or maybe a 1 in a 1,000-year event, since the consequences are so high, it's the cost of mitigating high impacting is only a tiny fraction of the trillions of dollars this will cause a country. And yet, the people like maybe technically a 100-year solar storm, what about a 1,000-year solar storm? The industry says if we hit with a 1,000-year, we can't do anything. And it would give the long-term electrical outage, maybe lasting for months, all your networks can go down. Mm-hmm. But the consequence of risk, if the consequences are so high, it's a fraction of the consequences worthwhile paying for. But the industry doesn't seem to want to look at a 1,000-year event.
And I think that as you look at risk, especially things that I would call black swan events, there are risks that are out there that you can try to mitigate, whether that's 9/11 or Katrina or some type of threat like that. You can't predict all of those high impact, low frequency events. There's some that we have an idea about that they could happen. They may never materialize, but as we work towards those, we may have other high impact events that we never planned for. So it is a balance to identify which things do we need to treat. There are some things that are much more present at hand, things like solar flares, and preparing for ground-induced currents is something that we can do. It's very realistic. But there are other areas that have higher impact that we may not be able to understand enough, let alone invest in, because it does require significant investment to mitigate some of those high impact events.
There's been a lot of talk about using data over electric lines. Have you considered taking the command and control off of the internet and using your own private network that would be run over these lines or over lines that run along with your electric lines?
I can't say that we've considered that, but I can tell you that as we operate the grid, we do not operate it over the public internet. So we already have a private setup with links to our transmission owners that we are able to communicate with them. There's certainly a reliance on internet technologies and other telecom, power, different areas that do have an impact in that, but we do have a separate way of communicating for our generation.
Oh, hello? I don't know. Okay. Hi. I had a quick question about like the software that you guys use specifically for the suppliers and for managing the loads and stuff like that. Is there a difference in how that software is developed to take a look at the security aspects or any sort of code auditing that's outside of the developer or the developing company? I was just kind of curious about that.
Sure. Well, I can address that at a couple levels. One is the software that we use is very specialized for energy management, state estimation, network. It really is very specialized for managing the power grid. And there are only a few suppliers of that software. With the attention to cybersecurity, all of the suppliers that we work with have a dramatically increased attention to cybersecurity, implementing things like software source code review and penetration testing, as well as partnering with industry as we identify issues and request that they follow up and close vulnerabilities. Everyone is much more receptive to that because of that. But even prior to cybersecurity being in effect, there's always been a very high emphasis on reliability. So making sure that the software runs reliably, using a lot of redundancy. So there is very special attention that's given to energy management systems and control systems.
Just a few more questions. We have two in the back and one up front, and we're going to wrap up.
Hi. The question being, with all the threats, potential threats that are out there, it's not like observation we're getting power shut down every day or anything like that. So it's coming. So, why would you attribute that to luck, or is it the fact that you have sensors out there, you're catching stuff, you're mitigating it, or due to your testing you're doing? Have you guys have insight on how effective these things are, and can you share that kind of stuff with? Because I mean, the good news is we're not getting shut down here every day because of these things.
Sure. Really, there's a lot to that. I think there's, at one level, the grid is a very resilient thing in and of itself. You have all of these electromechanical machines spinning with lots of momentum and torque and kinetic energy. So it's that physical layer itself that lends a lot of reliability. The blackout of 2003 taught us that breakdowns that happen at multiple points can cause those failures. And I think one of the big things that came out of that blackout was mandatory standards. And those mandatory standards from that are defined and managed by NERC as a result of orders from FERC have really pushed industry to be consistent in our way of managing the grid, making things much more reliable, so that the threats like we experienced in 2003 are hopefully mitigated dramatically, because they specifically address many of the issues that we encountered then.
And how about the cyber threats?
Cyber threats, it's an interesting area. Last year, or maybe a year and a half ago, I would have told you, well, cyber threats are out there, but they haven't touched the energy sector. Now they are touching the energy sector. We've seen a lot more attempts at either breaking into power companies or denial of service attacks. It's something that companies like PJM we're very attentive to and investing more and more. So far, there hasn't been anything that's caused a negative impact on the grid. We'll keep our fingers crossed that between the physical protections of the grid and everything that we're doing in terms of cybersecurity are helping to mitigate that. But I think one of the things that we talk about in many circles is it's not a matter of if, but when. So I think the big question will be, when that does happen, will we be ready to respond quickly and minimize the impact?
You mentioned the mandatory standards, and the electric sector is really the only sector in the United States that, because Congress has not been able to pass cybersecurity legislation, that really has any mandatory rules. That said, is there more that Congress should be doing, or are there other tools that you need to do your job better?
It's a great question. As I mentioned on that process slide, we require partnership. There's only so much that we can do as an individual company, so we definitely need the government involved in what we're doing. We cannot protect against a nation state. It's not our place to do that. We need to exercise due care and do everything that we can, but when it escalates to that level, it's those partnerships with the government that are going to be essential. And so we found already great partnerships in Department of Homeland Security. They have an industrial control systems cert that we work with. They're very collaborative. very helpful through incidents as well as in other security risks that we work in, whether that's vulnerabilities or mitigating threats that we're facing. So we find a lot of partnership there. We find a lot of partnership with NERC, although NERC is not a government entity, it is directed by the government, and so we find a lot of help and support there. So I think that those areas where we're able to share information bidirectionally, it's one of the biggest things that we can do to partner with government. I think that standards is an important thing, and making sure that we get good at consistent execution and following standards, but also rising above those standards and going further. But I think that the government can do a lot more with information sharing. And I believe that it is. One of the things in the executive order is really around information sharing, making sure that there are more clearances available to industry, that we have better ways of sharing information, that not all information really needs to be classified as high of a level as it is, and so how do we make that information that doesn't need to be classified at that level available to people who don't have those clearances.
Wow. Thanks everyone for the great questions, and thank you, Stephen, for the great lecture.
Thank you.
We have here at Chesapeake, we have a few traditions, first of which is our door prize, and we usually have our speaker draw the number.